I leaned over. All right. Takes 1.42 kilograms of water from 20 degrees Celsius to steam at 173 degrees Celsius. What total heat is needed? Okay, so understand that we're going to go from 20 to 100, and this is going to be liquid, right? And our C is going to be, so we're going to use MCAT for that, right? And this C that I'm going to use is the one for the liquid water. So this guy's going to be 4186, right? Our change in temperature will be, 20 to 100 is 80. And our mass, all these masses will be 1.42, right? Then the next thing that happens is we're going to go from liquid water at 100 degrees Celsius to gas at 100 degrees Celsius, right? So that's going to be vaporization. We're going to use this guy here, right? So that's going to be ml, right? Then so this is liquid plus gas, right? Then we're going to go in the gas phase. We're going to go from gas at 100 degrees Celsius. The reason I'm explaining this in such granularity here is that I think people don't understand, right? People want to use like 173, which we never would do, right? Or even worse, they'll use 153, or I don't even know. Okay, so we just got to be careful about what's going on. If you understand what's going on, this is not a hard problem. And then this is going to be MC delta T. But notice that when it's steam, it's easy. It's the easiest to heat up. Right? Ice is a little bit harder, but not much. And when it's a liquid, it's the hardest, one of the hardest things to heat up. Right? It absorbs a lot of heat per kilogram degree Celsius. So we're going to use for steam. We're going to use 2010. That was a good year. All right. That's when you guys were born, right? Okay, so we're going to just type this in. So 1.42. It's liquid water, so we're going to use this guy, right? So 4186. Our change in temperature is 20 to 40 is 80. All right, then we're going to go 1.42, and we're going to vaporize it, so we use that guy. I know it's 2.26 times 10 to the 6th, but that's the nice thing. It's nice to put them with the same exponent, right? And then we're going to heat up the steam, so it's still 1.42 kilograms. Right, but our C is that of steam, so 2010. And then we're going to go from 100 to 173, so that's a 73 degree difference. Right, it's not 173, it's not 153. Okay, so this guy represents 20 to 100. That represents 100 to 173, right? Okay, yeah, I think we got this right. Let's see if we get the right answer. 1.42, which you could factor out if you really have no life. Okay, so times 4186 times 80 plus 1.42 times 22.6 plus 1.42 times 2010 times 73. And I get, very unhelpfully, 3893086.2. Wish there was like an extension you could install into your TI calculator. Just commas. Could you do some commas? Right, so that is 3.89 times 10 to the 6th joules total. Okay, so just remember what it's got to do, right? If it starts at liquid water at 20 Celsius, right, it's got to heat up as a liquid, then it's got to boil, then it has to heat up as a gas, okay? Just draw, take your time, slow down.